here are some of the properties of vector addition, subtraction, scalar multiplication. So the first box in the yellow is the zero vector. So let's say you have a magnitude of 0, so a length of 0. That vector is 0. So in terms of I and j, there's no direction. So the vector I, or the vector 0, is 0i plus 0j. Again, in the second yellow box is the properties of vector addition and subtraction and multiplication. So notice these properties for commutative, associative, additive identity, and inverse, multiplication, distributive property, hold true. So you may want to pause and read through those properties. All right, so here's our example 6. We have vector v, which equals 5i plus 4j, so it's a linear combination. Vector w is 6i minus 9j. And what we want to do is complete this vector operation set. We want to multiply vector v by a scalar of 4. We want to multiply vector w by a scalar of 2. And then in between them is an operation of subtraction. So if you want to refer back to our previous slide, you're welcome to do so. Remember, when you do a scalar multiplication, you're distributing it all the way through. And then our vector operations of subtraction is right here. So here we go. So let's go ahead and 4v minus 2w. So first we're going to multiply that vector v by 4. So it's going to be 4 times 5i plus 4j, and then minus it, and then vector w, we're going to multiply it by 2. So 2 times 6i minus 9j. Now we're going to think of that scalar as like the distributive property. So here we go. So to simplify that, 4 times 5i is 20i. 4 times 4j is 16j. So there's the first distribution. And then you're going to do the same thing for the negative 2. So negative 2 times 6i is negative 12i. And then negative 2 times negative 9j is 18j. Now to simplify it, we're going to go ahead and think of these as combining like terms. So here is 20i and negative 12i. You combine them together like terms. So that is 8i. And then next pair of like terms is your 16j and 18j. When you add them together, you're going to get 34j. So you'll get a new vector as a linear combination.